Let's review for the quiz tomorrow. Quiz 7b, sections 7.2 and 7.3. Number 1 says solve each equation, and later we're going to learn a new technique. But for today, for this lesson, every one of them is going to be a problem where you can change the bases to be the same. And so what we can do in this problem is change the 64 into 4 to the third power. And that's nice because it's matching the other 4 over here to the first power. So what you've got then, 64 is 4 to the third, but that's raised to the 3n power equals 4 to the first. This is 4 to the first after all. Once you can get those bases to match, really all you have to do is look at the exponents. So we look at the exponents and see how it's number parentheses number. That means we're going to multiply them. 3 times 3n is 9n, and that's going to equal this exponent, which is 1. All right, so we got an exponent here, we got an exponent here. Don't think that that's 0 because there's nothing there. It's a 1. So let's solve the equation, and we're going to get n equals 1/9. Okay. All right. We're not going to do this. Okay. Number 3, they already match. 6 and 6, so great. So all we have to do is look at the exponents. Isolate the variable. Remember, that's a -1, so we're going to divide by negative. You can probably do that step in your head. Sometimes we get so hung up in the algebra, we think about using our common sense. -v equals 2, so yeah, of course, v has to equal -2. Number 5, this is the first time we've seen an inequality. But it really behaves exactly the same way as an equation. Just, use what you know about inequalities. We want to change the 81 into a 3. Does anybody know what that'll be? 3 to the... Anybody know? 3 to the third power? Maybe. 3 to the fourth power? Maybe. Let's check it out. 3 to the fourth power is 81. Yeah, that's it. 3 to the fourth power right there. So we see 3 to the -3x is greater than 3 to the fourth. The key is getting that matching base. Those two bases match. All you have to do is look at the inequalities, the exponents there. But this time, instead of an equal sign, we're going to have a greater than sign, greater than symbol. So we haven't seen this in a while, but when you isolate the variable here, when you divide by a negative, does anybody remember what happens with the inequality? Good. Okay, so you guys already know that. When you divide an inequality by a negative, it's going to flip the symbol. -4/3. X is less than -4/3. So we've got a fraction, so what? Big deal. Deal with it. 64 is kind of a big number. If you can't see what it is, you can start guessing. 2 to the fourth power. I'm going to go bigger. 2 to the fifth power. Go bigger. 2 to the sixth power. Okay, 2 to the sixth power. That's 2 to the sixth power. If you couldn't see that, you can always break it down. I know most people don't want to do this, but divide by 2, divide by 2, divide by 2, divide by 2, divide by 2. Break it down into a product of primes. I see 1, 2, 3, 4, 5, 6. That's 2 to the sixth power. So if you have a calculator out, you can just kind of guess around until you can get it. But otherwise, you can break it down and figure out that's 2 to the sixth power. 2 to the -3x is less than or equal 2 to the sixth. Once you've got that matching base, look at the exponents. -3x is less than or equal 6. We're going to divide by this -3 to isolate the variable, knowing that when that happens, we have to flip the symbol. X is greater than or equal -2. Now, in the future, we're going to get problems that will be impossible to do this way. We're going to have to do something else. And that something else is going to involve logarithms. So we need to know what logarithms are. Logarithm is like the inverse operation of an exponential. Logarithms go with exponentials, kind of like multiplication and division. Multiplication and division cancel each other out, right? Times and divide cancel each other out. Plus and minus cancel each other out because they're inverse operations of each other. They undo one another, and that's kind of what happens. Exponentials, logarithms, kind of the same thing. So what I told you to remember is that a log is equal to an exponent. When we're talking about a logarithm, we're talking about an exponent. All right, when we're talking about a logarithm, we're talking about an exponent. A logarithm equals an exponent. So this problem says rewrite each equation in exponential form. Well, if you've got this memorized, that a logarithm equals an exponent, then you're going to know that this is the exponent. Logarithm equals an exponent, so that's the exponent. How you read this problem, and you don't need to write this down, but you read this problem number 9 as log base 216 of 6 equals 1/3. It's important to understand that this is a base 216. That kind of helps you to visualize what the exponential is going to be. We're trying to rewrite it as an exponential. An exponential is going to have a base, and it's going to have an exponent. And the only other number is the 6, so that's going to be your equals. And so how we can look at this on a calculator, if we look at this 216 to the parentheses 1/3, sure enough, it equals 6. All right, 216 to the 1/3 power equals 6. All right, so all you have to really think about is a log equals an exponent. So I know this is the exponent, and I know this number is the base. If you understand which is the base and which is the exponent, this is easy. All right, base 2, exponent 6, going to equal 64. We already knew that though, right? 2 to the 6th equals 64. Is there a problem? Everything good? All right. Most people understand this better. You look at 2 to the 6 equals 64 and it makes sense. You know what's happening. All right. This problem is a little bit more confusing because we don't quite understand what a logarithm is yet. All right. But just understand that when I'm talking about a logarithm, I'm talking about an exponent. All right. Logarithm is an exponent. So the next problem says write each equation in logarithmic form. All right. So what I see is an exponential, but what I want is a logarithm. And so it's the same thing, really. You want to identify the base. This number's the base. And this number's the exponent. If you can identify the base and the exponent, then you should be able to convert to a logarithm. Because a logarithm, again, I don't need you to write this down, but a logarithm is going to be read as log base something of something equals something. All right, and so we know that the exponent goes over here, and we know that this is the base right there, and then that other number is the one that goes in that middle spot there. But I've got a log. We can see the base of this is 18, so that's a subscript of, well, this is what goes here, and your exponent is your equals over here, equals -2. The exponent is -2. The exponent is -2. Now, I told you yesterday, I believe, how to write this. Sometimes people have a hard time writing it. So, go back to kindergarten when you first learned how to write and how it fits on this line. This is how I would write it. You've got log, and then your base is 18, so that's real small. That's a subscript. And then your 1 over 324 goes here, equals -2. And 2's not big enough, but let's do this. All right, so sometimes people have a hard time sizing it up. They don't know which one's big and which one's small. The subscript, the base is the subscript. Okay, so again, identify the base. This is the base, and this is the exponent. So then you should be able to say log base 3 of 27 equals exponent 3. I know it's harder to understand a logarithm than an exponential, but it says pretty much the same thing. You've got a base and you've got an exponent. Finally, we can evaluate log base 2 of 4. And when you look at it, it looks kind of hard and you don't really understand what it is because you don't understand yet that a logarithm is an exponent. We're looking for the exponent that makes 4. That's what we're doing in this problem. And so if you know what you're talking about, you can just do it and you know the answer already. All right, you can do it in your head. But if you don't already know how to do it, here's what I would do. Right, equals x, okay? Equals x, and then do kind of what we did above when we converted to an exponential. I can see the base, this is the base, and this is the exponent. A logarithm equals an exponent. So if I write it in the other form, there's a base 2, there's an exponent x, and it equals the other number 4. If you change it to an exponential, a lot of the times that makes it easier to see what's happening. 4 is 2 squared. So I can see now that that exponent must be 2, x equals 2. Once you figure out what you're doing, you can do this problem in your head, and maybe the next one as well. Okay, log base 6 of 216. Think of it this way. We're looking for the exponent that makes 216. Raise your hand if you know what that answer is. A couple of you? Okay, good. That's not all of you, and that's understandable. I don't expect everyone to be able to do logarithms in your head, but I know some of you can. So we're trying to find the exponent that makes 216. So I just say equals x. I've got a base 6 and an exponent x, and it's going to equal that other number like this. So maybe that makes it more clear. 6 to the something power equals 216. And you can kind of play around on your calculator and say 6 to the second. Nah, that's too small. 6 to the third. That's a hit. There it is, right there, 216. Okay. I know that 216 is 6 to the third. So if 6 to the x equals 6 to the third, x must equal 3. Those of you that had your hand up, were you right? Did you know it was 3? That was right? Okay.